All right, welcome back. Today we are diving into a huge, a truly massive shift that's happening right now deep inside the data centers that power our entire digital world. You see, the AI boom is forcing a complete and total rethink of how servers are built. And you know what? A piece of technology you almost definitely have in your pocket is leading the charge. Let's get into it. So, this right here, this is the billion-dollar question that IT architects, engineers, everyone is wrestling with right now. The demand for AI. I'm talking large language models, crazy complex data analysis. It's creating a whole new class of problems. And the thing is, our traditional infrastructure, it just wasn't built for this. It really is a classic case of using yesterday's tools to try and solve tomorrow's problems. And we're hitting a breaking point fast. So, what are these problems exactly? Well, it really boils down to three major headaches. First, these AI workloads are incredibly power hungry. They send electricity bills straight through the roof. Second, all that power, well, it creates a ton of heat, which, you guessed it, needs even more power just for cooling. And third, and this is a bit one, you get these critical data bottlenecks. Your super expensive GPUs are just sitting there, literally starved for data because the rest of the system can't feed them fast enough. It's this vicious cycle of inefficiency that's just slamming into both physical and financial limits. Okay, so to really understand the solution, we've got to get to the core of the problem. And it all comes down to the processor, the brain of the server. For decades, the data center has been dominated by one philosophy, one type of chip. But now, its longtime rival is stepping into the spotlight. We're talking about a tale of two chips, x86 and ARM. Now, this is what's so fascinating. This chart lays out two completely different ways of thinking about how to process information. On one side, you've got x86. It's based on CISC, which is all about using these big, powerful, complex instructions. Then on the other side, you've got ARM. It's based on RISC, and it's built from the ground up for efficiency, using lots of simple instructions. This one difference in philosophy has this massive ripple effect on absolutely everything else, from energy use to how many cores you can pack in to what they're even good for. Let's break that down a little. CISC, which stands for Complex Instruction Set Computer, that's the DNA of your traditional x86 processors. I want you to think of it like a master chef who can chop, saute, and plate a whole dish with one single complicated move. It's impressive, it's powerful for sure, but it's also really resource intensive. It's great for your everyday applications, but it can be total overkill and pretty inefficient for really specialized jobs. And then you've got RISC, the Reduced Instruction Set Computer. This is the heart and soul of ARM. And it is the complete opposite approach. Instead of one master chef, imagine 100 line cooks, and each one is just doing one simple task, like just chopping an onion, but they're doing it incredibly fast. By working all together in parallel, they can get a massive amount of work done with unbelievable speed and efficiency. It really is that many hands make light work philosophy put into a chip. Okay, so here's where it all clicks. This risk philosophy. It directly attacks those big challenges we talked about right at the start. Remember the sky-high power bills, the crazy heat, the data bottlenecks? Well, it turns out ARM's design is basically purpose-built to solve exactly those issues. That's what makes it such a natural, perfect fit for the demands of modern AI. So how does it do it? Well, it really just comes down to these three key things. First, the energy efficiency is it's unmatched. You get incredible performance per watt, which slashes your electricity and cooling costs. Second, higher core density. You can pack way more processing cores into the same physical space, which means you're getting more out of your expensive rack real estate. And third, you kill those performance bottlenecks. That many core design is perfect for just fire hosing data to hungry GPUs, making sure your most expensive hardware is always working at its peak. All right, theory is great and all, but let's see how this actually plays out in the real world. We've got a fantastic case study for this, the Engine Star V Ultra Falcon. This is a server that was designed from the ground up to really unleash the power of ARM for AI. This quote just nails it. It really sets the stage. The key phrase here is seamless many-core configuration. See, that's what it's all about. It's about taking that risk philosophy, all those simple cores working together, and using it to deliver a totally new level of performance. And here is the payoff. Get this, when they put it to the test against a 4th-gen Intel Xeon processor, and they both had the same powerful NVIDIA GPU, the Falcon delivered a staggering 4 times faster AI inference performance. That's using an AI model to actually make a prediction. 4 times. That is not an improvement, that is a revolution. But hold on, it's not just about raw speed. It does all of this while using way less power. We're talking a 2.8 times reduction in power consumption. For a data center operator, that is an absolute game changer. It directly tackles that first huge pain point we talked about. And because of that awesome core density, you also get a 3 times reduction in physical space. That means you can fit more servers and a lot more computing power into the exact same rack you already have. It's just about doing more with less on every single front. Less power, less heat, and less space. And if you need a picture, well, this chart says it all. This is a real-world test running the Llama 3.2 language model. Just look at the difference in tokens, the pieces of words it can process per second. The ARM-based Falcon is cranking out nearly 4,100 tokens. The Xeon, about 1,000. This isn't some small incremental improvement, folks. This is a fundamental leap in what's possible. So what's under the hood making all this happen? Well, you're looking at up to 128 of those Ampere Ultra performance cores. You can pair that with a massive 4 terabytes of memory. And it's already optimized for all the big AI software you're using, like TensorFlow and PyTorch. And the whole thing fits in a standard 2U rack mount box. Incredible. But here's the thing. This ARM revolution isn't just about these top-tier monster AI servers. The same exact principles, efficiency, density, make it incredibly versatile for a whole range of other critical jobs in the data center, and even out at the edge. Let's just take a quick peek at the broader family here. You can see right away how that core ARM architecture gets tailored for different tasks. You've got the Falcon, that's your AI powerhouse. But then you have models like the Bull for storage and the little Chameleon for edge computing. And each one has a different balance of cores and memory for its specific mission. The VLX Bull, for instance, is all about data. It's loaded up with 12 drive bays, making it the perfect choice for a high-capacity, super energy-efficient storage or backup server. It's the reliable workhorse that's making sure all your data is safe and ready when you need it. And then you have something like the VSQ Mini Chameleon. This thing shows the power of ARM in a totally different arena. It's this tiny, low-power server that's designed to live out on the edge, and it's powerful enough to manage 100 CCTV cameras for a surveillance system. It's just maximum efficiency in a mini package. So, what all of this really comes down to is a fundamental rethinking of the data center itself. For years, the big race was all about raw clock speed. Who had the fastest single core? But in the age of AI, in the age of these massive parallel jobs, the new measure of power is efficiency. It's all about performance per watt, performance per dollar, and performance per rack unit. Which leaves all of us with one final and, I think, pretty crucial question. The demand for AI, it isn't slowing down, it's speeding up. So as you plan for that future, what architecture is going to be the foundation of your infrastructure? Are you going to stick with the old philosophy, or are you going to embrace this new era of efficiency? It's a choice that's going to define the next decade of computing. Thanks for joining us.